Um, Today I want to go again over the problem called design Facebook post search um, from HelloInterview. Um, so for this problem, we need to design a system where user should be able to create and like posts. User should be able to search post by keyword, and user should be able to search results and sort them by recency and like count. We have a system which has 1 billion daily active users, 1 trillion posts altogether, and constraints of that system is that we shouldn't use search engines like Elasticsearch or pre-built full text index. Okay, so now what sort of functional requirements we want to cover? We want to design, maybe let's start with cap theory. So from the cap theory, we want a system which is highly available, highly consistent. What would be more important for that particular system, like Facebook post search? I would say more important would be availability rather than consistency. Over consistency. Yeah, I would say for that system it would be sort of more important to just have the system responding quickly all the time, rather than users sort of if users if different users see different results, not totally up to date. In this particular system it's okay. If it was banking application, that would be a big problem, because that would cause some sort of lack of trust from the users. But in this particular system it's okay. If we had to design a system post search, maybe for something more more unique and more important from like security perspective, maybe I don't know, it will be some sort of search for crime database or things like that. Possibly for that it would be better to choose consistency, but in general for that kind of system, availability would be more important. Uh, and yeah, users should be able to create and like post. Users should be able to search posts by keyword. I would say that search should be relatively quick. Yeah? So I would say low latency for search. Search results should come back within, let's say, less than 2 seconds. But also it should be shouldn't be large delay when it comes to searching for newly created posts. So I would say those posts which were just created, they should come up, maybe not immediately in the next searches, but I would say within a minute from their from publishing them, they should appear in the search results. So I would say low delay for newly created posts. Let's say less than 1 minute. And also for sorting and counting, I would say yeah, the latency should be low. That kind of search should work quickly. When it comes to sorting, another question would be like how important is sorting? How important is does the sorting need to purely and 100% correctly reflect actual counts? So we can ask here a clarifying question. Uh, so I will ask how accurate sorting need to be. Can it be just a rough estimate? For this system, exact precision isn't. In sorting is critical. Approximate sorting based on recency and like count is acceptable. That's something which kind of important thing to add to our non-functional requirements. If the system was much more, if the accuracy was more important, then that would require much it would cost or it would require much bigger changes in our system. So, but for this particular question, we can say that approximate sorting doesn't need to be totally accurate. Okay, so let's say those are our non-functional requirements. Let's get feedback. Okay, great. Keep on. Okay, you identify all non-functional requirements for Facebook's post search, including eventual consistency, low latency, and quick indexing for new posts, and you properly contextualized each requirement to a specific system and quantified your latency and indexing time expectations. Your approach to prioritizing availability over consistency, KPRM, shows good understanding of distributed systems trade-offs for a search system. Okay, that's perfect. Okay, and what we can improve is consider specifying a target for approximate sorting. For example, how accurate the results need to be, or what metrics would you use to measure such quality. Okay, that's good. Good idea. In search systems, approximate sorting needs clear metrics to be actionable. For example, you might specify 95% of top 10 results should match what the perfect algorithm would return. That's kind of good metric to remember. 95% of top 10 results should match what perfect algorithm would return, and relevance score must be within 10% of optimal. Having quantifiable targets helps during implementation decisions and allows you to measure whether your system is meeting requirements during testing. Okay, and what's the example? What's the sample answer? This is a straightforward search system. Will assume eventual consistency is fine and put some parameters on it 1 minute so that we have a target for our design. We'll also set some latency guardrails that are realistic for a search page. Okay, not eventually consistent. Index post within 1 minute of creation, low latency for search. So 90% of searches happen to be in less than 500 milliseconds. Okay. Okay, so that's good. Let's move to next part. What are the core entities of the system? Write your answer in the green box on the whiteboard. And okay. So the core entities will be post. It will be user. It will be also like. We want to sort by like count, so we need to keep track of those likes in some way. Post. Search by keyword, and I would say those are sort of like main ones which come to my mind. Post, user, like. Let's see. You correctly identified all the core entities needed for the Facebook post search, post user, and like. Your answer was concise and focused on just listing the entities without unnecessary details. Okay. Post, like, user. The system has very basic core entities. We're indexing posts which may have likes and are created by user. Okay, so that's perfect. Let's go to the next question. Now, what are the external REST APIs that your system will expose in order to satisfy the functional requirements to search posts and create like posts? Okay, so now for creating a liking post, that's where we need our first API. So for creating post, so we're gonna need a post, a post, an endpoint, and let's call it, um, let's say, um, uh, maybe I can call it just post, although it's kind of sounds weird because the post verb and post verb here. But yeah, let's just leave it like that. And um, the post, well, in the body we'll need to put, um, the details of the post. In the header we can have like a JWT token, which will store also user, so then we don't need user here. So here we mostly gonna need like content. We can have so date, we could put the creation date, or we can just uh, get it from the time on the server. Maybe like some sort of like attachments or images, that kind of things. Okay, so that'll be for post. For likes, um, so for likes, we could have, well, also post endpoint, um, or probably more appropriate would be put. Yeah, so we'll be updating the count. Um, let's go like that, and again we're gonna have our header, proof of location, and in the body, do we really need body for like, kind of, we could even use get request for that, but and but we need to support also liking and unliking. So maybe in the body we're gonna have some sort of like type, and that will be enum of like, let's say, like and unlike, or unlike. um, yeah. Now for searching by keyword, that's where we gonna need our get endpoint. Let's call it, again, posts, and we can pass our parameters here. So we're gonna pass keyword in query, in query params, and also, well, we can provide like other parameters here, like because we want to sort it here, so we can pass like, let's say, sort by decency, and sort by likes count, like count, and that could be publicly available endpoint, or we can have some sort of authentication, maybe to generate more search more specific to the user, and that will be useful. um, okay, yeah, yeah, that's for searching, and sorting. We're gonna have essentially the same endpoint, yeah, just be passing more parameters. Yeah, so that's pretty much like the basic API routes which we're gonna need. Okay, yeah, we can specify a response format, making that unclear which data structure clients should expect when retrieving the post. A clear response format would help front-end developers understand how to parse and display the result. In a REST API, the response format should be clearly defined so clients know what to expect when making requests. A typical response for a search endpoint may include an array of post objects, pagination details, and potentially metadata about the search results. During an interview, specifying response formats demonstrates your attention to detail and understanding of complete API design, which interviewers look for when evaluating system design. Yeah, that'll be a good thing to include. Adding pagination parameters, that's also another suggestion. Your search endpoint would help manage large result sets and improve performance. Pagination is essential when dealing with large data sets, as it allows clients to request specific subsets of results rather than the entire collection at once. You could add parameters like page size and page token for cursor-based pagination, or page for offset-based pagination. This approach not only improves API performance but also demonstrates to the interviewers that you're thinking about scalability and user experience with large results sets. The sort by parameter based device. I should just have one in your example, which could cause confusion because you're using a single parameter with one value or different approach for multiple sort criteria. In URL, when the same parameter appears multiple times, like sort by recencies, most frameworks will either use only last value or create an array of values depending on implementation. Or for clarity in API design, consider using a single parameter with comma separated values or dedicated parameters for each sort criterion. Okay. This makes your API more predictable and easier. Okay. Versioning your API paths would make future API evolution easier to manage. That's also a nice idea. API versioning allows you to make breaking changes to your API without disturbing existing clients. For example, if you need to change the structure of a response or add required parameters, you can create a new version, AG version 2, while maintaining the old one. During interview, demonstrating awareness of versioning shows you're thinking about maintainability and evolution of your system over time. That's sort of a good idea. We can add. So here we could add, let's say version 1 post. So we can sort by, to avoid confusion. We can do it like that, and that would return essentially array of posts. Yes, that's what I covered. And also as another parameter, we could add pagination, and let's say if we use off-based pagination, we can provide page size 10 and page number, say 2, or we could do like cursor, or they call it page token for cursor-based pagination. For search, I would probably use for search results. Probably I would use offset pagination, offset-based pagination. For newsfeed, I would definitely use. Because you also want to like share those results, and then maybe it'll be easier. We can specify sort of response for put, we can get, let's say, just 200 OK. for creating posts. We can get our post back. Yeah, we correctly identify all the core API endpoints needed for the system, including post creation, liking functionality, and post search with keyword and sorting capabilities. Your API design follows RESTful principles with appropriate HTTP methods for each operation: post for creation, put for updates, get for retrieval. Okay, you include authentication requirements through HTTP headers, which is important for user-specific operations. Okay, let's see sample answer. Okay, so they have get request version sort by query page size, page token. Okay, so they use page token. We have post. Okay, yeah, we want to return sort of like next page. We want to usually return also pagination information. And our post, gonna in the body we're gonna have content and post. Yeah, we also need to pass post ID, and yeah, that's actually a good point. Yeah, we should actually. So that's also post. Okay. Yeah, we can do it like this. We can have post version 1 like post ID. And in the body we can have boolean. Yeah, I think that would be actually better. Is post is put better than post? Yeah, that's kind of debatable. I mean that you can make both of them work. Okay, let's go to the next question. Okay, how will users create posts and like them? Okay, so we want to sort of create like high level overview. Okay, so let's see, allow. So we're going to have our UI where users see our posts. So our UI, and let's say when user creates posts, so he provides that content here on the UI, then clicks post or publish, and then we can use API gateway for things like routing, security, load balancing. We can sort of delegate lots of functionalities to API gateway. Authentication as well, and then that will pass it to the server, which will actually handle the particular functionality. So for creating posts, we would route it to let's say post creation service, and that post creation service, its main job would be essentially to save it in some sort of database. Could be Postgres, could be other database types. So that'll be for this endpoint for creating new posts, but now for liking posts, well, for liking posts will be sort of similar, just gonna have usually for a large system like this we would like to separate them in different services. Okay, we want to update whiteboard to include data schema with the tables and fields necessary to satisfy this part of the system. You can add them directly next to the database. This is important so that we can understand how the data is structured, how it will be used in the system. Okay. Yeah, we can do it. So here we're gonna have well, our posts database, and they're gonna have ID, and they're gonna have user, and they're gonna have content, and created that, updated that, deleted that, and all those other properties. Well, for things like likes, we would have essentially like a separate service. So let's call it likes service, and because of the large amounts of likes, we could keep it in a separate database. And here we're gonna have likes, they also gonna have ID, timestamp, user ID, and maybe that boolean which tells us if it's like or unlike. And could be also like maybe you can well, technically we could have things like deleting or updating. Maybe that would be useful, but it kind of depends on the specifics of the system. And well, for the search, so for the so for the search, we would well, we could also create like a separate service which we're gonna call search service, post search. And well, here we could either, well, let's say in the basic example we could just run search on our Postgres database, but in reality, to make it more efficient, we would need to either use something like Elasticsearch, which is not allowed by that question, but in this case we can create something like Elasticsearch on our own. That will be in optimizations part of that question. Okay, you provide a comprehensive high-level design that clearly separates concerns with distinct services for post creation, post search, and likes functionality. your design includes important infrastructure components like API gateway that handles routing, security, and load balancing. You thoughtfully structured your database schema with appropriate fields for both posts and likes, which will support the core functionality requirements. Um, your whiteboard diagram shows connection from the API gateway to all three services, but your verbal explanation um, could more clearly articulate how the like service processes like requests and integrates with post database. Yeah, because we could also somehow like keep update of likes on the posts. Here we can keep like all the events. In your diagram, you've shown post version 1 like post ID going through the API gateway, but you didn't clearly explain how this request flows to the like service and how that service records the like in its database. In designing distributed systems, it's important to articulate the complete request flow for each user action. This helps interviewers understand your thought process and ensures you've considered all the necessary interactions between components. Okay, yeah, makes sense. Yeah, yeah, kind of ran out of time, so that's why it was not recorded on here on this website. Um, yeah, the sample answer is let's keep it simple. We create two services for posts and likes and route them. Okay, so they very much simplify that totally. Um, okay, the next question: how will users be able to search by keyword? Start simple. We'll optimize it later. Yeah, so to search by keyword, yeah, we're gonna use again. I think actually the previous question was asking only about creating posts, if I'm not wrong. But yeah, anyway, so we already have that route here. We would have post search service, and well, in the most basic system, we would just okay, so we're gonna have our our search endpoint, where we're gonna provide search parameters, um, and then we're gonna have a separate post search service, which in the most sort of the easiest the most basic system, that post search service would just query database and return that result. But obviously that's not gonna scale very well. So that's kind of like very simplistic view. In to make that system scale, we would need something like Elasticsearch, which is not allowed by that question. But we can still build something similar to our to Elasticsearch. So, for example, when the user actually saves that post, we can create something called DB trigger. So when that post is searched, we're gonna have that kind of event here, and DB trigger, and so that event can be then well, we can put it in some sort of queue, or could be kinesis as well, especially for likes. Kinesis would be probably better because it's more scalable. But here we could have so those events, just to sort of to make them more durable and retriable, we can have them in, let's say, we're gonna say SQS, and then we can have like another service which picks up messages from that SQS and then builds something which builds that inverted index type of store like Elasticsearch. So I'm gonna say and then we can query that inverted index. Okay, what went well? You designed a clear search endpoint with appropriate query parameters. Okay, keywords by page size page that routes through an API gateway to a dedicated post search service. You provided both a simple solution, direct database query, and more scalable approach using an inverted index for keyword searching. Your design includes considerations for how many new posts would be indexed from database triggers and the queue system. The connection between the post search service and the inverted index could be more clearly illustrated on your whiteboard diagram to show how search queries utilize this index. Okay, so in your diagram you mentioned inverted index, but haven't shown how the post search service connects to or queries this index. An inverted index is crucial for efficient keyword searches as it maps words to documents containing them. During an interview, clearly illustrating this connection helps illustrate your understanding of how search functionality works at the fundamental level and shows you thought through a complete data flow from user query to search results. Yeah, I mean, kind of could maybe show like example that when users search for, let's say, beans, then you know. Then we can say here that the word beans is mentioned at post 111 to again like have a post with IDs. So that would be like a very simple like, inverted search, and it gets more complex when we have more specific situations like multiple words, or if you want to deal with searches which have like some spelling mistakes and so on. It can get more complex, but let's keep it simple for now. The flow from database triggers to SQSQ to building the inverted index could be more explicitly drawn to better visualize these important aspects of your search functionality. Okay. In your diagram, I would recommend adding clear arrows showing how data flows from the database trigger to SQSQ and then to the service that builds the inverted index. This visual clarity helps interviewers follow your thought process about how search data is processed asynchronously when explaining complex data flows in system design interviews. Explicit visual connections between components demonstrate your understanding of how data transforms through the system and helps the interviewer evaluate your solution without having to make assumptions. Yeah, I mean, I added arrows here. Maybe I didn't read them correctly. Like maybe I need to add like box to make a hello interview like read it. Okay, what's the sample answer? Um, yeah, so we have search service, and okay, so they kept it very simple. We're going to add as a search service as the endpoint handling search requests. We'll assume for now that we can simply search the post DB, but we will probably note to our interviewer that this obviously won't work at scale. We'll get back to it later. Okay. Okay, yeah, let's go to next question. And how will users be able to sort their results by recency and like count? Um, okay, um, yeah, so how users will be able to sort it? Well, so users will be just providing the parameter. Um, that parameter will contain either word recency or like count to denote that that's the way we want to sort it. And then um, we can so well then the simplest way would be to have our post search service um, to to just like query um, things from the keyword based on from that inverted index, and if it's based on recency, then we can um, we can sort of query just like well, we can the simplest way would be to grab all of them, and then like on the server we gonna just take the um, whatever is page size, and that's what we're gonna return. um, and for a like count, so yeah, that kind of make it more complex, because likes we store in a separate database. So well, we will need to like query a certain amount of let's say we want to return 10. We're gonna query we need to query them from inverted index, and then we need to query for each post. We need to query like the like, and then just return those with highest amount of likes. Another way would be to like also to keep that inverted index up to date. Okay, we can keep that inverted index up to date, and here we can update the like count, and maybe here, like, what's that? Well, here we can have like inverted index for recency, and inverted index for counts. Like we can have them separately. And, well, in that way we can make that search more efficient. Before evaluating responsibly, update your design to meet the constraints of this problem. Do not use search engine or yeah, I didn't use Elasticsearch. I mean, I kind of wanted to write here more, but it blocks me. Um, yeah, I want to have here like let's see, the post containing beans, and we could have we could have them by let's say by recency, uh, and we can have another by counts. And those could be like sorted sets. Okay, you provided a clear approach for implementing sorting by adding a sort by parameter to the API that accepts recency and like count values. You design separate indexes for recency and like counts in your inverted index structure, which enables efficient sorting. Okay, you consider multiple implementations approaches for like account sorting, showing good system design thinking. Your whiteboard diagram effectively shows the data flow and components needed to support the new sorting functionality. Okay, let's see example. Okay, so they keep like cache, and then search service fetches likes amount from the like cache. We can do it like that. Um, to be able to sort by like count and create it out, we need to able to retrieve them. For like count, we can set up a like cache, maybe Redis, um, where we can cache counts from our like database, like otherwise has one record per user. Um, we will counts like where we can cache counts from our like database. The device have one record per user. Okay, we'll invalidate recalculate it whenever like for given post. Yeah, so yes, that's kind of important difference, yeah, because we have here we store like pretty much like events, Here we store counts, and we need to fetch counts. Yeah, so yeah, that's kind of like another way. The way I did it is, I think it's more optimum, which is like we keep our inverted index up to date. Obviously, we cannot do it on each event; that would be way too heavy. But we can here we can have like again we can streamline that in some way. Okay, how can we scale the keyword search to support trillions of posts? Um, well, to support keyword search for trillions of posts, yeah. So, well, for that we're gonna need that, inverted index essentially, um, and that's something which can happen um, in memory. So we could use like sorted sets for like keeping them sorted, and then we can grab, just like let's say 10 most recent posts or 10 posts for that keyword with highest accounts. Well, so that will be like one of the way we need to keep. If we have trillions of posts, we're gonna have hundreds of trillions of like events. So probably that's something which we should like throttle here. So we can have like so we can like store them. Well, so instead of like having db trigger here, we can have as pretty much as they mentioned, we could have likes counts cache, yeah? Likes counts cache, and every time when we achieve a certain threshold, yeah, that could be, let's say, powers of 2, yeah. So um, if we go if we like get to that threshold, only then we gonna update our inverted index. So in that way we don't spam our database, yeah, with let me draw it again. Yeah, update after approaching threshold like powers of 2. So we are allowed to do it, yeah, because in our non-functional requirements, we determine that those counts, those sorts don't need to be 100% accurate. They need to be pretty accurate, but not 100%. So, if we sort of have some sort of threshold of updates, then we gonna limit queries which we send to that database to our inverted index, while at the same time we're gonna keep that pretty much up to date. Okay, you design a comprehensive solution using an inverted index with sorted sets to efficiently handle keyword searches across trillions of posts. You implemented a smart throttling mechanism using power of two thresholds to avoid overwhelming the database with updates while maintaining reasonable accuracy. Your design separates concerns well with dedicated services for post creation, search, and likes management. You considered both recency and like count as sorting criteria in your inverted index implementation. Consider explaining more clearly how the keys and values are structured in your inverted index, specifically how keywords map to post IDs and how the sorted sets maintain both recency and like count ordering. Um, for example, you may structure your inverted index with keys like um, keyword timestamp, keyword likes to map that map to Redis sorted set containing post IDs. This allows efficient retrieval of posts by keywords sorted by either recency or popularity. In an interview, clearly articulating this data structure shows you've thought through both the write and read paths of the system, which demonstrates practical knowledge of how to implement scalable search functionality. Provide more detail on how the query side logic retrieves and processes results from the inverted index when handling search requests with different sorting criteria. When a user searches for a keyword with a specific sort order, you should explain how the system would efficiently retrieve the relevant post IDs from the inverted index and apply the requested sorting. For example, with recency sorting, you may describe how you would access a sorted set keyed by the keyword where post IDs are already ordered by timestamp, why for popularity sorting you would access different sorted set where posts are ordered by like count. The query side explanation demonstrates your understanding of how to translate user requests into efficient data retrieval operation, which is crucial for scalable system. Okay, in the sample answer they're using search indexes, post service ingestion, search service, and they have that kind of keyword comma like keyword comma creation. It's kind of like Redis style. We've outgrown our basic solution and need to scale. We'll rely on a reverse index between keywords in the user search and the post that match. We'll have two separate indexes, one that is pre-sorted by creation time and that other which is pre-sorted by like count. We store this in Redis using sorted sets. Then when search happens, we can take the top element from that index and return to the user. We'll create a separate ingestion service which will be triggered when a post is created or like happens. It will tokenize the post, extract all the words, and update their respective indexes. Yeah, I can update that so it will be like keyword. Yeah, I'm gonna essentially use sorted sets here. Okay, how would your system handle the case where a particular keyword appears in billions of posts? Would your current inverted index design need any modification to maintain performance in this scenario? Okay, so I think I'm gonna finish that here as a part one. Later on, I'm gonna finish that question and record part two. Yeah, thank you for listening.